class, today we're going to talk about Chapter 52, Dosage Calculations. Don't that just sound like fun? Yes, I know some of you probably like, no, Miss Tezza, this does not sound like fun. This sounds like a bunch of work. But it's okay. We're going to get through it. That's the whole point of talking about it and us being in class. And when we come in class, we're going to actually work through the process. It's not as hard as you may think. All right, well, let's get started. All right, so we're going to talk about your role as a medical assistant to ensure safe dosage calculations. We're going to talk about different types of systems of measurements and their common uses. We're going to talk about how to convert among systems of measurements. We're going to talk about how to execute dosage calculations accurately and how to calculate doses based on body weight. Okay, so ensuring safe dosage calculations. Now, you as a medical assistant, you may sometimes be called on to calculate a dose of a medication prescribed by the licensed practitioner. Calculating the medication dose must be extremely accurate because medication errors can be life-threatening. All right? So, accurate mathematical skills are needed, but in a busy healthcare environment, attention to detail along with common sense will also be needed. Okay? Now, looking at your screen, outer numbers are called extremes. The inner numbers are called means. What we tend to do is cross multiply or multiply the means and extremes to solve the problem. Okay, you see that your external or outer are called extremes. Your internal or inner are called means. When you cross multiply the numbers, you do that so that you can solve the problem. All right. Now, the most common systems of measurements used in the United States for pharmacology and drug administration is called metric system. The other two systems are apothecary and household. Your drug measurements will focus on volume and weight. Okay, did you get that? Your drug measurements will focus on volume and weight. Volume refers to the amount of space a drug occupies, and weight refers to the heaviness. Length is also a basic unit. In the metric system, measurements are based on multiples of 10. Okay? You have liters, and liters are used to measure volume. It's also used to measure grams. Grams are used to measure weight. Now, prefixes. Prefixes are added to indicate multiples or fractions. The abbreviation for liter is a capital L, but the abbreviation for grams is a lowercase g. The purpose of this discrepancy is to lower the possibility of someone interpreting a lowercase l as a 1. The abbreviation CC, that means the same thing as mLs or milliliters. And ml is always abbreviated with a lowercase m and a capital L. But we use mLs just so we can avoid interpretation of a CC as being 2 zeros. So that's the reason why we use mL. Now, the apothecary and household systems are not generally used for dosage calculations, but the apothecary system uses units such as fluid ounces, pints, and quarts for volumes, ounces, and pounds for weight. The only household units used for measurement are units of volume. They include drops, teaspoons, tablespoons, ounces, cups, pints, quarts, and gallons. Now let's take a look at conversions within and between measurement systems. Now when we talk about converting, we're talking about converting one metric unit of measurement to another, which is similar to multiplying and dividing decimal numbers. The proportion method is used to calculate unit conversions between systems of measurements, okay, which we're going to talk a lot about this in class. To multiply correctly, the numbers must be converted to the same system of measurement. And yes, Miss Cousin, we're going to talk about how we convert that, and we're actually going to do some problems on how to convert this. Now, you as a medical assistant, you may have to convert patients' weight, fluid volumes, and medication weights. So on your screen, you can see that there are a few conversions that you have to look into to converting. So some of those converting factors will be converting pounds to kilograms. It can be kilograms to pounds. And when we're talking about pounds to kilograms, in order to do that, a pound is equal to a kilogram by using kilograms times 2.2. If we're going to convert kilograms, then kilograms is pounds divided by 2.2. So if we want to convert pounds to kilograms and kilograms to pounds, we've got to do pounds is equal to kilograms times 2.2. And if we're going to convert kilograms to pounds, we've got to take the pounds and divide it by 2.2. All right? Now, if we want to convert milliliters to liters, then we're going to take and do liters times 1,000. If we're going to convert liters to milliliters, then we got to do milliliters divided by 1,000. Okay? If we're going to convert milligrams to grams, then we want to take grams and multiply that times 1,000. And we're going to take, if we want to take and convert grams to milligrams, then we have to take milligrams and divide it by 1,000. Now, if we want to convert milligrams to micrograms, we got to take the milligrams and multiply it times 1,000. And if we're going to do milligrams and convert micrograms to milligrams, then we have to take micrograms and divide it by 1,000. If you paid attention to the trend, what we're doing is we're taking, if it's like for instance, the micrograms to grams, then we had to take the gram and multiply it by 1,000. Well, which one is bigger? Is it micrograms or grams? Grams is bigger, so we're multiplying by 1,000. When we're trying to convert grams to milligrams, then we're going to take milligrams and divide it by 1,000. It's smaller. Okay? Let's keep going. All right, so the proportion method used for unit conversions can also be used for dosage calculations. It is the oldest method for calculating dosages. It is set up as a ratio with the left side being known as quantities and the right side being the desired dose and the amount to give. Your multiplication is then done of the means and the extremes, which will be equal to each other. So some of you probably seen this if you took algebra. You probably done this when doing algebra. That was how they did the proportionary method. The formula method for dosage calculations is based on the desired dose, which is divided by the dose that is on hand and multiply the quantity to have the solution of the amount to administer. Before doing the final calculation, you want to convert measurements to one system. So converting to one system is very, very, very important. Okay? And we're going to talk about this more in class because we're going to actually do some practices. All right, so a drug dose. A drug dose may be determined based on the body surface area or the weight of the patient in certain cases. Some drugs for children are dosed according to the body weight in milligrams or kilograms. The first step is to accurately convert the body weight from pounds to kilograms. 1 kilogram equals 2.2 pounds. So before calculating doses based on body weight, you need to know that. Doses are often expressed as milligrams per kilograms per day, or it can be milligrams per kilogram per dose. This is something you also must understand when doing dosage calculations. All right? This is the end of this chapter, as it was not long. You'll have a more understanding of what we was talking about in this chapter once we start executing it using dosage calculations in class. We will work together and we will conquer this together as a class and as a team. So I will see you guys back in class doing dosage calculations. Bye for now.